Welcome to Bald Guy DIY. In this video, I'm going to show you how you can run two PySimpleGUI interfaces at a time, completely independent from each other, using multiprocessing. I really love creating interfaces using the PySimpleGUI library for Python, and especially using them on the Raspberry Pi and Raspberry Pi touchscreen for escape room puzzles. There are several different ways to run multiple windows using the PySimpleGUI documentation and some of the demo programs, but with the programs available on the website and other documentation I could find, I couldn't find an answer for a specific thing that I was looking for. I'd really like to be able to run two GUI windows completely separate from each other, having no interaction and sharing no variables, so that one doesn't affect the other. The particular case that I have in mind is in an escape room puzzles where I can generate window after window after window, but in between those windows I get a flash of the Raspberry Pi desktop that is really undesirable. So in this video I'm going to show you how you can use the multiprocessing library, or multiprocessing depending on your pronunciation, how you can use it to create separate processes for each GUI so they're completely independent of each other. So when you initialize and close one, it has no bearing on the other. That way I can create a solid background that remains in place and hides the desktop even when I launch multiple different instances of new GUI windows. It's really not that complicated, so let's get into it. Jump right into the code here, and you can see that we import PySimpleGUI as SG, which is standard, and for multiprocessing, going to import the process function. I wrote a real basic GUI here that auto-generates some buttons in a grid, and if you want to see more about how to create these, I have a video both on PySimpleGUI and on a Sudoku that uses buttons and this kind of layout. But for the sake of this video, we're simply going to create multiple instances of this GUI so that I can demonstrate how these two independent processes work. I'm going to create a new function, and I'm going to call it new window. The whole GUI that I created is going to be indented to be inside that function. The number of rows and columns that I want to be able to adjust is going to go in the function in the options or variables that are going to be declared, and you can see them here. Now, in order to actually cause a GUI to be generated, I simply need to go here and call the function by putting in a row number and column number that I want of buttons. As I run it, you can see that I forgot to put a colon. I put a semicolon instead, and so now if I change it up, I'm not getting the right amount. When I looked at my code, it's because now that I've declared those explicitly, I don't need to put them inside the function itself, and so I'm just going to comment out where I declared them when I made the GUI before. Now the row and column variables that I declare are working correctly, and you can see here how it works when we just call one instance of the GUI. It creates the number of buttons that we need. You can also type out the variables that you want to use by putting in row equals, column equals, but it's not necessary as long as you declare them in the order that you want them. As you can see here, same thing with 3, same thing with 6. Whatever number of rows and columns of buttons you want, you simply just have to change those variables to be them. Some of them fit better than others. The particular dimensions of the size of the window I created, it works better with 5 and 5, but you can see here you can just play with it, and all you need to do to create a new GUI with a different number of buttons is just simply to change these numbers here. Now of course if you're creating the actual GUI, you would have a bunch of event handling of what happens when you push those buttons, but for the sake of just demonstration, I'm just going to create a bunch of instances with different numbers of buttons just so you can see why you would want to do this. In an escape room puzzle like I'm creating, I want to have several different puzzles use the same computer or touchscreen interface. So to be able to move from puzzle to puzzle to puzzle as the user completes it, I want to be able to generate a new instance very easily. So that's what happens when you put them in order like this. You have to close one in order for the other to be created, and every time it moves from new window to new window, you get a flash of whatever is beneath it. In this case, you're getting that black flash of the window for VS Code, but on the Raspberry Pi, I'm getting the desktop of the operating system. To clear that up, I'm going to create a new function which declares a new window, and this is just going to be a solid background with an empty layout in the same size of the original windows. Then when I add that background function here, you can see that indeed it is going to work and generate the same size. Because it's independent from the other function, we do need to add that same event loop, and so when you see it here, I'm going to take out the print statement because it's unnecessary. There's no functionality there. But you can see when I run it, you get the background, but it's still in order. It runs first and then all of the other things sequentially, and it gives you that same black flash in between. Instead, we're going to put all of these that I want to run in a new function called main window, and we're going to use multiprocessing in order to create the ability to run both the background and those other windows at the same time. So to do that, you just declare a variable name for each process and then call the process function, with the target being the name of the function that we want to call. Here I accidentally put it as new window. It should have been the function I created called main window, and I'll fix that in a minute. In order to initialize it, you must use this if name equals main format, and then you're going to call the variable name and the start function in order to create them to go. I'm also going to add a little bit of time delay or sleep between those two function calls because I want to make sure the background has a full chance to load in the correct place before I put the next one on top of it. If I run this, I find out it doesn't load because I'm calling the new window function instead of the main window function, and my variables are not declared. So once I figured that out and put main window instead, when I run it, here you can see it looks like the window I want to run, but here's the background right behind it, which means that when I close that first instance, there is my background. It doesn't go anywhere, even though I'm moving through all of those other instances of the GUI. If we run it again and just click through them, you can see that even as I close and open every single one of those next windows, the background stays in place because they're fully independent as separate processes. If I was to comment out the background process and run it again, you can see more clearly what I'm talking about. Here, every time we close one of those windows, we get the flash of what's behind it. But if I remove the comment and put it back to what it was, the background stays in place as I do this, and so we don't get that flash of the background. As a result, it looks much more uniform and like it's part of the same interface, and not like it's a homemade feel where it always feels like what's beneath is shining through. It feels much more polished and works great for my application. That's all you need to do to create these separate processes and to make these GUIs function independently. You could add more processes and have more independent however you want. So I hope you can see how easy it is to create separate processes for each GUI that you want to run independently, and then they have no bearing on the outcome of the others. You can open, close, generate new GUIs, and they're not going to interfere with the ones that you already have open. If you want to share the variables together, well, some of the other methods in the PySimpleGUI documentation might be a little better, as they do a better job of communicating those. It's harder to share variables between separate processes. But if you look up how to share variables using multiprocessing, there are some tutorials on how to do that online that you can apply to the GUIs as well. Whether a frustrating search to do this yourself has brought you to this video, or you're just looking for inspiration as you create your own GUI windows, I hope this has been helpful. And if it has, let me know by giving the video a thumbs up and subscribing to the channel, as I post new content every week on a wide variety of DIY topics. If you have a comment or suggestion, leave it below or send me an email. My information's in the description. And until next time, in all your DIY projects, whether you want to do them all at once or one at a time, don't be afraid to be bolder.